Hello, scientific people. How are you? So, today I'm going to make a video on Pythagoras theorem, and I see this as a very basic necessity for all science students, and this is widely applicable in mathematics and physics as well. So, a lot of numericals related to distance and displacement in physics are based on the Pythagoras theorem. So, I have decided to make the video on the same, and this video would be covering the proof of the Pythagoras theorem, basic meaning in terms of area as well as the application. Finally, I would be talking about the triplets and one illustration, and I would be ending up this session. So, Pythagoras theorem was given by Pythagoras, and he was a Greek philosopher and mathematician. He had deep interest in music as well. So he was also called as the Pythagoras of Samos, as he belonged to Samos. And since I told you that he was interested in music, I'll just tell you, I'll just share one small part that he wrote in connection with the science, and very beautifully written. There is geometry in the humming of strings. There is music in the spacing of the spheres. Wow, wonderful. And we are not going to go in depth about the meaning of this, but hopefully you can make a connection that he was very much interested in music as well. Fine. So here we have a right angle triangle in front of us. Let me give the name as ABC. And it is right angle at B. And out of all three angles, as you can see, that this is the biggest angle, largest angle. These two are acute angles. So the side opposite to the largest angle is also the longest side. So since this is the largest angle, this has to be the longest side, and it is called hypotenuse. This side is called base. This side is called perpendicular. So you may name it as adjacent and opposite as well, but I generally use perpendicular, base, and hypotenuse. Base is the side, the lower side of the triangle on which the triangle actually stands. And the perpendicular is the side which is perpendicular to the base, and hypotenuse is the longest side. Now, Pythagoras theorem states that you can only apply Pythagoras theorem if you have a right angle triangle. So in any other triangles, you can't apply this theorem, right? So Pythagoras theorem states that square of hypotenuse in a right angle triangle is equal to sum of squares of remaining two sides, which means the square of hypotenuse, that is AC square, that is equal to sum of squares of remaining two sides. This is the Pythagoras theorem, as simple as that. Now, where it is used, so if I give you any two sides of the triangle, you can find out the remaining third side. Like if I consider this as 3 centimeter, this as 4 centimeter, so I can find out the AC square and then finally the length of the hypotenuse. So AC square is equal to AB square, that is 3 square plus 4 square, which means this is 9 plus 16, which is 25. So AC square is 25. So AC is equal to root of 25, which makes it as 5 centimeter. So hypotenuse is 5 centimeter. Now, this pair of three integers which are satisfying the Pythagoras theorem are called triplets, Pythagorean triplets. So I have 3, 4, and 5 as triplets, and with regard to this, I have discussed almost at the end of this video lecture. I just want to tell you that these triplets are not any set of numbers that can satisfy the Pythagoras theorem, but these have to be positive integers. So now let's move on to the next part. So this is our main right angle triangle having length of the perpendicular A, length of the base B, length of the hypotenuse C. Now what I have done is, guys, I have constructed three squares, 1, 2, 3, and the length of this square is the length of the hypotenuse. So basically I constructed a square from here, and the length of the square was taken as the hypotenuse length. So if this is C, this is also C. That means the area of this square, that means this part area is length into breadth, that will be C square. So C square is going to be the area of this particular square, and another square I have constructed over here whose one side is equal to the length of the base. So if this is base B length, then this is also B. All square sides are equal, and this side, this area of this particular square is going to be B square, length into breadth, right? And the third square that I have drawn, whose length I have taken it as the length of this perpendicular, that is A. This all sides becomes A because all the squares, they have equal length. So this area is going to be A square. Now, what was Pythagoras theorem? Pythagoras theorem was C square is equal to A square plus B square. Now, what does it mean over here? That the area of the largest square, which is made out of the hypotenuse, is equal to the sum of areas of the other two squares, which are being constructed by taking the length of the perpendicular and the base. So this is the other meaning of the Pythagoras theorem in terms of the areas of the square. So you may add up the areas of this square, and you will be getting the area of the largest square, which is constructed by taking the length of the hypotenuse, right? Okay. So let's move to the interesting part, that is the proof of the Pythagoras theorem. And I find this method, area method, to be quite easy. Rest, there are many methods available, but I found this method to be very easy, so I am sharing this with you. Now what I have done is, guys, I have taken a square. Now I have divided this length. We know that squares are having equal length, so all four lengths are equal. Now I have divided this length into two parts. One part is A, another part is B. So this part has length A starting from here till here, and then from here to here this length is B. So basically this square has length A plus B. Now on the other side also I have taken this length as A, and this is B. Over here again this is B. Like this. So the entire square was divided into A and B length, but here if I draw A, then adjacent would be B. Here I draw A, adjacent would be B. Here I draw A, then the adjacent would be B, like that. Now these 4 points, I'm going to connect them, I'm going to join them. Great. And what you see is a smaller square that is produced inside, right? So square inside a square. Now I'm going to call this length as small c. So since this is a square, length is going to be c all over. Now some of you might be confused that why this is a square. Just imagine if I make this as a rectangle like this. So opposite sides of the rectangle would be equal. I'm talking something like this. So suppose this is B, this is B, this is A, this is A. So this is the so this becomes the diagonal of the rectangle. In the same way, here again, this becomes A, this becomes B. So this is again the diagonal of the rectangle, and same rectangle, because rectangles are having same length A and B, and diagonal of the rectangle having same length are same. So here what am I going to do is I am going to find the area of the outer bigger square. So area of bigger square that is equal to a plus b multiplied by a plus b, length into length. So it is a plus b into a plus b. So it is going to be a plus b the whole square. This is going to be the length of the square multiplied by length of the square. So area of the square. Correct. Now the area of the smaller square is going to be length into breadth. So again c into c, so that is c square. But guys, just imagine that if I add these four areas into this area, then I'll be getting the entire area or not? Because these four smaller areas plus this area would be the entirely area of the bigger square. Now this shape is triangle and all four triangles are identical, and I know that area of the triangle is equal to half into base is B, into perpendicular, so that is A. Same goes over here, all four triangles, they have same area, half into B into A, half into B into A, half into B into A. So that means, so area of four triangles shall be equal to 4 times half into B into A. That turns out to be 2 getting cancelled, so this is 2AB. So this is the area of four triangles, this and this, and I'm going to add the area of these four triangles into the area of this square, smaller square. So I'll be getting the total area, right? So c square is the area of the smaller square plus 2ab, that is the area of the bigger square, that is a plus b the whole square. Now I'm just going to open up the bracket, 2ab, that is equal to a square plus 2ab, this is an identity in mathematics, plus b square, and we can see that 2ab getting cancelled, and what I end up with, you know very well guys, this is c square is equal to a square plus b square, none other than our own Pythagoras theorem, right? So this method was an interesting and easy method to derive Pythagoras theorem. Now let's move on to a small activity, right, where it is used. So let me give you an example. So here I have with me a black box. This is a rectangular box, hollow from inside, right? And what do I have now? I have the length of this. I have the length of this. Now, if I have the length of this and this, I can find out the length of the hypotenuse that starts from here and end over here, correct? So let me show you where it is. I am talking something like this. So if this is, say, length A, and if I call this as length B, then this would be length C, that is the diagonal of the rectangle, and I can find out C square is equal to A square by B square. So basically if I give you these two lengths, you can find out this length. But I'm not interested in this, guys. I'm interested in finding out this length. Hope you get it. In 3 dimension, as you can visualize, that was the diagonal which is touching the base of the rectangle, this one. Now this rectangle is quite high. It has got height also. So this height, and if I give you this, you can find out this. This is again the diagonal starting from one point at the bottom of the rectangle to the other opposite top side of the rectangle. In 3 dimension, it is becoming a bit difficult for me to show you. Hopefully you can see it like this. This forms a right angle triangle, angled over there. So if I am given the height of the triangle, height of the rectangle, and I have found out this one, So this square, the length of this square and this square would be giving me the length of this red pen square. So basically this red pen is nothing but starting from here and ending over here on the top edge. So this is how you can also find out the diagonally opposite sides of the room. So our room is basically, this is our smaller room only. So if I start from here and if I end at the top, because this is my hypotenuse, when I calculate this square plus this square, I get this square, and this square plus this standing height square would be this one, the one which I was talking over here, this one. And in slant you can see that it's a right angle over there, right guys? So you can be asked a lot of questions on the in the mathematics related to this. So one such question is displayed over here in front of you. And you can just pause the video and think over this question. So now let's solve that question. It's an interesting problem which can be solved with the help of Pythagoras theorem. So here is a wheel which is given to you whose radius is 1 meter. Now this wheel actually performs rotational motion as well as linear motion. So this wheel actually goes in the forward direction also, and it is rotating also. So let me consider a point here on the ground, right? And we know that if wheel performs one complete rotation, this point will again reach over here, right? And the linear distance traveled from here to here, when wheel finishes one full revolution, that distance is 2 pi r, right? So if the wheel finishes half the rotation, so this point will reach over here. This wheel turns and this point reaches exactly diametrically opposite side, like this. And this distance traveled would be equal to half of 2 pi r. So basically this distance is pi r. So from here to here, this distance is pi r. And we know that this distance from here to here is the diameter. So this is basically twice the radius. And this angle is 90 degrees. And in the question it was asked, find the displacement of the point. Displacement is the shortest distance between 2 points. So this point reaches over here. So the displacement is this. Now, how can I find that displacement? That is, let me call this as C. So applying the Pythagoras theorem, C square is equal to this square plus this square, that is pi r the whole square plus 2r the whole square. So this is pi r the whole square plus, I can even open up the bracket, 4r square. So let me do that. Pi square r square plus 4r square. This is equal to c square. So c would be equal to basically the under root of pi square r square plus 4r square. Then c would be equal to, I can pull out r square common, pi square plus 4 and whole under root. So this is equal to r will come out. So this is our answer, pi square plus 4. And if you are given the value of radius, that is 1, so r is 1, so your final answer is pi square plus 4 only. So this is our final answer, guys. We need not to solve it more further. So hopefully you might have understood that where do we use the Pythagoras theorem. It is when out of 3 sides of a right angle triangle, if you know 2, then you will be able to find the third side. So last but not least, let's discuss about the Pythagorean triplets. Triplet means, so let us learn that how many types of triplets are there. Pythagorean triplets are of two types: primitive triplets, scaled up triplets. 3, 4, 5, 5, 12, 13. So if you select the length of these two sides as 5 and 12, you will get this as 13. If you select this as 7 and 24, this you will get 25, right? So these are all the primary triplets. So basically primary triplets are those triplets whose HCF is 1. Whose HCF is 1, or they are themselves divided by themselves. So you can divide 3 by 3, 4 by 4 and 5 by 5. So they have the common factor with which they can be divided, that is only 1, right? All are co-prime numbers. So basically this is one triplet, second triplet. There are total 16 primitive triplets over here. Now scaled up triplet means what? Suppose if I multiply these all three numbers by 2, so I'll be getting 6, 8, 10. This also becomes a triplet. You can check it by yourself. 6 square plus 8 square, that is 36 plus 64, that becomes 100. So root 100 is 10. So another triplet, if I multiply this by 3, then I'll be getting the another triplet as 9, then 4 3s are 12, and 5 3s are 15. This is another triplet. If I multiply it by 4, I'll get the third scaled up triplet. In that way I am having multiple infinite number of triplets for this primitive triplet. Again, if I multiply these three numbers by 2, so I would be getting 10, 24 and 26. This becomes another scaled up triplets. But guys, if you look carefully, the scaled up triplet will have HCF 1 and some other number also. These are not co-prime. In the same way, if I multiply this by 3, I'll get the another triplet. Multiply by 4, I'll get again an infinite number of triplets. Here again, you can find infinite number of triplets are there. So there are total 16 primitive triplets, and you can have infinite number of their own scaled up triplets. Now guys, most important thing. Not all triplets which agree Pythagoras theorem are called Pythagorean triplets. Suppose if I draw a triangle like this, and giving it as a name ABC, and suppose this is 1 centimeter, this is 2 centimeter, right? And if I apply the Pythagoras theorem, AC square is equal to sum of squares of the other two sides. This becomes 1 square plus 2 square. This is 1 plus 4. This is 5. So AC is equal to under root of 5, which is not a Pythagoras triplet. So you can't consider 1, 2 and root 5 as Pythagorean triplet. Pythagorean triplet has to be positive integers. This is not a positive integer. This is in p by q fraction form. As you can see over here, all these are positive integers. So if any set of three numbers which are obeying the Pythagoras theorem cannot be considered as the Pythagorean triplets. So hopefully guys, you have understood what I was trying to talk about the Pythagorean triplet. If any suggestions, please do comment in the comment section, and thank you very much for watching the video guys.